For this video, we're going to be learning about the Pythagorean inequalities theorem. And this theorem allows us to determine whether a triangle is a right triangle, an obtuse triangle, or an acute triangle. So it allows us to classify a triangle. And so this theorem says that for any triangle ABC, where C is the length of the longest side, so really important, C is the length of the longest side, the following statements are true. If c squared is less than a squared plus b squared, then triangle ABC is acute. And if c squared is greater than a squared plus b squared, then triangle ABC is obtuse. And so you can kind of see what this looks like here. And so with our right triangle, like we talked about in previous videos, that is when c squared is equal to a squared plus b squared. We see it looks like this. However, when c squared is bigger, we see that we end up with that obtuse angle, and when c squared is smaller, we end up with that acute angle C. So let's go through some examples. So given the side lengths of the triangle, determine whether the triangle is acute, obtuse, or right. So we're looking to see how c squared compares to a squared plus b squared. However, remember that c is the longest side. So I'm even going to make a note of that above here. C is the longest side. The other two, it doesn't matter which one you assign as A or B. So here my longest side is 6.1, so that means that 6.1 needs to be on the left. So I'm going to see what 6.1 squared is compared to 4.3 squared plus 5.2 squared. Well, when I do 6.1 squared, I get 37.21. 4.3 squared, I get 18.49. And then 5.2 squared, I get 27.04. So, and then when I add on the right-hand side, 27.04 plus 18.49, I get 45.53. So now I need to compare these. I see that 37 is less than 45. So I have that c squared is less than a squared plus b squared. And so since it's less than, I see from my theorem, that means that triangle ABC is acute. Okay, let's try another one. So here I have 3, 4, and 6. So my longest side here is 6, so that means that needs to be on the left with my c squared. So I have 6 squared, and then we'll compare that to 3 squared plus 4 squared. Well, 6 squared I get 36, 3 squared I get 9, 4 squared I get 16, 9 plus 16 I get 25. So here I see that c squared is bigger than a squared plus b squared. And then from my theorem, when it's bigger, that means that it is an obtuse triangle. Let's try one last one. So now I have side lengths 2.1, 2.8, and 3.5. First step is I want to identify what my c is, so I need to figure out what my longest side is, and that's going to be 3.5. So I have 3.5 squared. And I'm going to compare that to 2.1 squared plus 2.8 squared. Well, 3.5 squared, I get 12.25. 2.1 squared, I get 4.41. Plus 2.8 squared, which is 7.84. Now when I add those together, 4.41 plus 7.84, I also get 12.25. So here, c squared is equal to a squared plus b squared. So that means that this is a right triangle.